Welcome to Lesson 5.2, Definite Integrals by Area. In this lesson, we're going to go over properties of definite integrals, how to take left and right-hand approximations, how to take midpoint and trapezoidal approximations, and approximations by area. Properties of integrals. These are the main ones you need to know, and it only applies to continuous functions. Number 1. On the integral from a to b, c dx equals c quantity b minus a, and this is used to find the area of a rectangle, as c is a constant. On the interval from a to b, quantity f of x plus or minus g of x dx equals f of x dx from a to b plus or minus g of x dx from a to b. This says you can split the functions and keep the same boundaries if you're adding or subtracting. Property 3 says you can move a constant outside the integral. Theorem 4 says if you change the integrals, the area becomes negative. So instead of the area being from b to a, it's now a to b, and it's also negative. Theorem 5 states that between a to a, f of x dx equals 0 because there's no area between a line. Here's an example of property 2. If f of x dx from 0 to 2 is 33, and f of x dx from 0 to 12 is 41, what is f of x dx from 2 to 12? F of x dx from 2 to 12 equals f of x dx from 0 to 12 minus f of x dx from 0 to 2. This is 41 minus 33 as given to us in the problem, which equals 8. Now we're getting into some left and right hand approximations. As you can see in the first graph, the rectangles are delta x apart, and in this case, delta x equals 1. To find the left-hand approximation, you use the y value of the leftmost point as the height of the rectangle. So the area equals 1 quantity f of 0 plus f of 1 plus f of 2 plus f of 3 plus f of 4 quantity. These are all the left-hand approximations, and the total gives you 6.146, and this is an underestimate because the function y equals root x is an increasing function. Now, if we were to use the right endpoints instead of the left ones, we would be including more area than is actually under the curve. Since it's an increasing function, then the calculated area is an overestimate. For the second graph, still y equals root x, the area is 1 quantity f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 quantity, and this equals 8.382. On a decreasing function, the left-hand limits would be an overestimate, like you see on the top graph, and the right-hand limits would be an underestimate, as you see on the bottom green graph. Because these approximations are not very accurate, it is better to use the midpoint rule. To write the integral from a to b, f of x dx equals delta x, quantity f of x sub I, plus all the midpoint y values of the rectangles, plus f of x sub n. N is the number of rectangles in this graph. In this case, it's 5. The trapezoid rule is an even better approximation. The notation for Riemann sums is f of x dx from a to b equals delta x over 2 quantity f of x sub 0 plus 2 f of x sub 1 plus 2 f of x sub 2 plus 2 of all the integrals from a to b plus f of x sub n quantity. If you look at a graph especially, you can see that the endpoints are only added once compared to the points in between the interval, which are added twice. Note that the trapezoid rule is the average of the left and right-hand approximations. In the homeworks, you might be given a problem involving a table. For example, find the area using trapezoids. We know that delta x is b minus a over n, and in this case delta x is 15 plus 10 over 5, which equals 5. So on the interval from negative 10 to 15, f of x dx equals 5 over 2 quantity f of negative 10 plus 2 f of negative 5 plus 2 f of 0 plus 2 f of 5 plus 2 f of 10 plus f of 15 quantity. So t of 5 is 100 units squared. This is relatively the same process for midpoint approximation, just use the midpoint rule instead. However, given a table with unequal x values, you would have to multiply delta x to each term using the area of a trapezoid. For example, find the area using trapezoids. T sub 4 is f of x dx from negative 10 to 9 equals 1/2 quantity delta x of f of negative 10 plus f of negative 7 plus delta x of f of negative 7 plus f of 2 plus delta x of f of 2 plus f of 3 plus delta x of f of 3 plus f of 9, quantity. This equals 26 units squared. Note that unequal x values will not work for midpoint formula. The points need to be given to you in a table or on a graph. Now for area approximation by known shapes. Note that the area is signed in this example. Part A asked for the area between negative 6 and negative 4, and if you look on the graph, you can see a rectangle and a triangle make up this area. By using known formulas for the rectangle and known formulas for the triangle, we can determine that the area between those 2 points is 9. Part B is similar, but instead we're going to subtract the area of a quarter circle from the big rectangle. By using known equations for a rectangle and known equations for a circle, we can determine that the area from negative 4 to 0 is 24 minus 4 pi. In Part C, they are asking for the area between 2 and 6, so we have to use a negative area because it's below the x-axis. In this case, it's negative 1/2 times 2 times 2 plus 1/2 times 2 times 3, which is a triangle, above the x-axis, and then times 3 plus 1, which is a little rectangle at the end. Total area is 4. Some common mistakes include not multiplying the 1/2 in the trapezoid rule, which is very common. 2. Not multiplying delta x in both the trapezoid and midpoint rules. Number 3. If f of x is neither decreasing nor increasing, it is not possible by hand to determine whether the left and or right hand approximations are over or under estimates. Thanks for watching!